All right, Math 9 here is a short video on divisibility rules. We covered these a little bit more in depth in our workbooks and in the longer video on section review 1. But here's just a quick reminder on how we can determine what numbers are divisible by. I'm only going to focus on a few of the major ones. So, divisibility rules. It helps to know what a number is divisible by, so we can just start dividing it. So every single number is divisible by 2 if it is even. Now, what does that mean? That means it is a number that ends in 0, 2, 4, 6, or 8. So, as an example, can we divide 38 by 2? Since the last number is an 8, yes, we can. 2 goes into 3 once with one remainder. 2 goes into 9, or 38, or sorry, 2 goes into 18. 9 times. So 2 times 19 is 38. Watch the video on division to understand the short division I just did there, but this will focus on divisibility rules. So that's 2. Every even number is divisible by 2. Let's do one more. 256 divisible by 2, of course, because it's even. 2 goes into 2 once, 2 goes into 5 twice with one remainder, 2 goes into 16 8 times. So as long as the number is even, it can be divided by 2. So 3 is really cool. Take the digits of the given number and add them up. If the total of the digits is divisible by 3, then the number is divisible by 3. So as an example, did you try to divide 159 by 3? Well, 1 plus 5 plus 9 is equal to 15. 15 is divisible by 3, so the number is. So then we can go ahead and do that division. So 3 goes into 15 5 times, no remainder. 3 goes into 9 3 times. So it's super helpful to be able to start dividing numbers down. You'll see how this comes in handy when we get to factoring our primes into primes. So knowing when you can divide by 2, when you can divide by 3, and other numbers like that. So another one, doesn't matter how big the number is. Let's say 12,350, 5, 8, 10, 1. So total those digits up. 1 plus 2 plus 3 plus 5 plus 1. Well, that's 5, 6, 7, 12. Now, even if you're like, well, I don't know if 12 is divisible by 3, you can actually total that up too. 1 plus 2, 3. So, yep, everything's divisible by 3. 3 goes into 12 4 times, no remainder. 3 goes into 3 once, no remainder. 3 goes into 5 once with 2 remainder. 3 goes into 21 7 times. Again, the division video will help you with your division, but this helps you with identifying what a number is divisible by. So that's 2 and 3. 3 is awesome. I don't have it in this video, but 9 is similar. You can divide by 9, but obviously the digits add to 9 instead of 3. So it's the same concept, but I'm not going to cover it in depth in this video. So, well, what about 6 then? And this comes into understanding factors. 6 is equal to 2 times 3. So if a number is divisible by 6, it has to be divisible by 2, and it has to be divisible by 3, which means it's divisible by 6 if rule 2 and 3 for divisors works. So what does that mean? That means we need an even number, and we need the digits add and then divide by 3, right? So a number like, let's use 18 as an example. 18 is even, and 1 plus 8 is 9. 9 divides 3, so we can divide it by 6 because it satisfies both 2 and 3. So 6 goes into 18 3 times. Let's get a bigger number here. How about 24,057? Nope, sorry, that won't work. Obviously, it's not even. So let's change this to 48. So that's an even number, and if we total those digits up, we get 18. So we can divide this by 6. 6 goes into 24 4 times, no remainder. 6 goes into 0 0 times. 6 goes into 4 0 times. With 4 remainder, 6 goes into 48 8 times. So if a number is divisible by both 2 and 3, it's divisible by 6. Last two here. When is a number divisible by 5? Well, just think $5 bills. 5, 10, 15, 20, 25, so on and so forth. So every number either ends in a 5 or ends in a 0. So that is our divisibility rule for 5. It ends in 5 or 0. So if you have a number that ends in a 0 or a 5, you know you're going to be able to divide it by 5. So 5 goes into 23 4 times with 3 remainder. 5 goes into 34 6 times with 4 remainder. 5 goes into 45 9 times. If a number ends in 0, I'll say 300. 5 goes into 30 6 times with 0 remainder. 5 goes into 0 0 times. So 5 or 0. 5's easy. And then this last one here is also quite easy. 10. Basically, this was, think about your $10 bills. All right. So it has to end in a 0. And if it's divisible by 0, you literally break the number down into the number in front and you cut off a 0. So 4 times 10. Or if you had 3,070 divided by 10, well, it's going to be 307 because 307 times 10 gets you 370. But just to show you, 10 goes into 30 3 times. 10 goes into 7 0 times with 7 remainder. 10 goes into 70 7 times. So that's 2, 3, 6, 5, and 10. Now 4 is a little interesting. If you think about an even number, if you divide an even number, so 18, say by 2, you get 9. I can't divide 9 again by 2. If I could, then I'd be divisible by 4 because I would have divided by 2 and then again by 2. So you need a number where the last 2 digits are divisible by 4. So for instance, 256. Is 56 divisible by 4? Well, let's just check. 4 goes into 5 once with 1 remainder. 4 goes into 16 4 times. So since 56 is divisible by 4, this entire number is divisible by 4. So 4 goes into 25 6 times with 1 remainder. 4 goes into 16 4 times. So it's pretty interesting with 4s. You got to look at the last 2 digits. All right, so another one, 244. Well, 44 is divisible by 4, so the whole thing's going to be divisible by 4. 4 goes into 24 6 times with no remainder. 4 goes into 4 once. So there you go. We got these interesting divisibility rules for 2, 3, 5, 10, 4, 6, and then there is one for 7. It's quite confusing, so just try and divide by 7. And you'll see when we would need to do that when we get to primes. But otherwise, knowing where to start by, can I divide this by 2? Can I divide it by 3? You're not guessing. You end up getting more strategic. So keep these divisibility rules in mind. They come in super handy when we get into factoring. All right, thanks so much, and I look forward to the next video.